This is looking at differentiation of polynomials. So we've got a rule for differentiating polynomials, and it's this rule here. So if you've got y equals x to the power of n, then dy by dx, or when you differentiate it, it equals n x to the power of n minus 1. Now, quite simply, this means you bring the power down the front, so your n comes down the front, and you just subtract 1 from the power. Might be easier if we just look at some examples. Before we do, we'll just a point that dy by dx can also be written as y dash or f dash of x, and you usually follow along from how the question's asked to how you answer. This will become apparent soon. Here we've got y equals 5x squared. So if we look at when we differentiate it, we're going to call it dy by dx because we're differentiating y with respect to x, and it becomes 10x. The reason why is that the 2 comes down the front with the 5, and then the power of 2 drops by 1. So if you take 1 away from 2, you get to the power of 1, and x by itself is just to the power of 1. Here's another example. Y equals 4x. Anything with just x to the power of 1 to start with, the x just drops off it. So dy by dx in this case will be just 4. And the last wee example we've got on this slide is y equals 3. So any constants, any numbers without any x's, when you differentiate it, it just becomes 0. Essentially they just drop off. So let's look at some slightly different examples. So we've got this one here. Y equals 6x squared plus 9x minus 3. So we're just going to follow the rules with it. So we've got dy by dx. So the 2 comes down the front with the 6 and becomes 12. And the x squared but now becomes x to the power of 1. So that's where the 12x comes from. Now we've got 9x there. That's just 9x to the power of 1. Remember from the previous slide, that if that happens, the x just drops off and you end up with 9. And any numbers or constants at the end just drop off or become plus 0. So here's a slightly longer one. So just work through each bit. Now this one's called f of x. So our answer is going to be f dash of x. And here's our answer here. So the 4 comes down the front with the 3 and it becomes 12. The power of 4 now becomes power of 3. The 3 comes down the front with the 6, so it becomes 18. The power drops by 1, so the 3 becomes a 2. Again, the next one, power comes down the front. 7 times 2 is 14, x to the power of 1. And then this one is just minus 2x. The x just drops off, so it becomes minus 2. And any constants at the end just drop off. Just be careful too that pluses and minuses here all match up as well. We'll look at 2 more examples. So this one involves fractions. So just a reminder about our fraction work. So we've got f of x. So our f dash of x. So when we bring the 4 down the front, you just multiply the top line by the 4. So it becomes 8 over 3. And we drop the power by 1, so it becomes x to the power of 3. 2 times 3 is 6. X to the power of 1 over 4. And the x, that's remember just 1x, so the x just drops and it becomes minus 1. We can simplify this a little bit more. 8/3 is fine, but this 6 over 4 can simplify down to become 3 over 2. And one more example, again with fractions. Written slightly different. You see the x has been written on the top line with the numerator. Same rules apply. So we just multiply the top by the power. So it becomes 21, x to the power of 6. Just leave the denominator, it just stays the same. And for the next one, 5 times 2 is 10, x to the power of 1 over 3. And then minus 4 just drops off and you just end up with 0. And that's just the introduction on how to differentiate polynomials.